Hi, myself Dinesh, Assistant Professor from Department of Mechanical Engineering from SNS College of Technology. In our previous videos, we have seen what's BIPV and then the principle. In the previous videos, we have seen what's BIPV, the principle, the advantages, and what are the important introduction, like what are the advantages by using these things. Okay, here we are going to see the economic analysis in this part. Here, as we see in this graph, we can clearly identify this is the capital cost, operational cost, and LCOE cost. Okay, so the module cost is high, and then which the cost will yeah, decrease drastically, like for the installation, and then investor and BOS and soft cost. Okay, the main purpose of this BIPV is to give energy to our building, and as well as to improve the overall aesthetic looks, right? So the whenever we are going to use not only BIPV, any solar system, the initial cost will be higher, but as for a long time, the maintenance and also the overall efficiency, and when comparing all this, we will get more beneficial than traditional method. Okay, so next one, the life cycle costing and payback period analysis for BIPV installation. As we seen in our earlier, we know that the initial cost is very much higher, and then the operational cost, the maintenance is less, and the life of the PV cell is comparatively high when it's compared to other things, right? So the first one is we are in the life cycle we are going to see initial investment. So assessment of upfront cost including material, labor and design. Okay, first we have to assess the upfront cost including the materials, labor and what type of design we are going to provide for the particular building. Okay, these are the things which will determine the initial investment. Next one is operational phase. Yeah, in the operational phase, analysis of energy saving, maintenance, and potential revenue generated over the system lifespan. Okay, these are the things which we are going to um, determine the operational phase. Okay, so for analyzing any operational phase, we are going to consider the energy savings. Okay, instead of exterior energy, our BIPV system will generate energy, so it will reduce some cost. And then the maintenance of all the photovoltaic cells which we are going to replace in the traditional building, and then the potential revenue generated over the system lifespan. Okay, during the entire building life span, how much how much unit of energy we are going to produce. Okay, these are the things which will determine the operational phase. And then end of life. Okay, considering a decommissioning and recycling cost, minimizing environment impact. Okay, whenever it comes to solar, we know that it has a very good environment friendly when it's compared to other things. So this is what the end of life means. That means minimizing the environment impact, like reducing the overall pollutions. So the payback period for BIPV system are typically 5 to 10 years, okay, which influenced by local energy prices and incentives and system efficiency. What are the challenges? Okay, what are the challenges in implementing the BIPV? Okay, so it's a very important topic when it comes to BIPV. The first one is installation complexity. So it requires a specialized skill and coordination between trades. Okay, we need a special skilled workers to install the BIPV in the long buildings, and there should be a proper communication between the employers in order to get more efficiency. Then early integration of BIPV specialist in design phase. While designing this building, we need a early integration so that we can generate energy at from the start itself. Okay, this is what the installation process. Okay, these are the things we have to consider while installing a BIPV. And then efficiency limitations. Performance can be affected by architectural construction and shading, right? While we construct, we have to expose the PV cells direct to the sunlight. If the building construction is not in that way, it will reduce the overall energy generation. So that's an important things we have to consider. And then advanced module design and detailing shading analysis is required for this BIPV system. So maintaining for BIPV is generally low, but specific cleaning and inspection protocol are essential to ensure optimal performance for a long period. Thank you.